Greetings again everyone, welcome back to my channel. Here we have another algebraic exponential equation that we're going to solve. So in today's lesson we are going to solve x in the situation where 8 to the power of x plus 2 to the power of 2 times x is equal to 150. As usual, you can pause this video and see if you can solve this one by yourself. If not, then let's solve this one together. So I'll write my solutions down below. Also, please feel free to check out my playlist on how I solve other algebraic exponential equations. So our problem states that we have 8 to the power of x plus 2 to the power of 2 times x is equal to 150, and we are given to find the value of x. We start by simplifying 8 to the power of x. 8 to the power of x can be rewritten as 2 to the power of 3, and we bracket that powered by x. And so we just rewrite 2 to the power of 2 times x is equal to 150. And here we will now apply our algebraic law, laws of indices, where we said that you have 8 to the power of m in brackets powered by n is the same as a to the power of m times n. Or we could even express that as a to the power of n times m. Now with this understanding, we can rewrite our equation as 2 to the power of x in brackets powered by 3 this time plus 2 to the power of x in brackets powered by 2 is equal to 150. And now from here we say let 2 to the power of x is equal to y. So we will be using our y variable to substitute for the value of 2 to the power of x. You will see how this comes in neatly as we continue to solve our problem. Now this therefore takes us to the point where we have y cubed plus y squared. So we take the powers of 2 to the power of x in both situations. So we have y cubed plus y squared is equal to 150. So now we can take our 150 and bring it to the left hand side of the equation, where it's now a positive and it's going to go over to the left hand side as a negative. So that therefore leaves us with y to the power of 3, or y cubed plus y squared minus 150 is equal to 0. Now here's a unique trick that we can use here in this problem, where we can take 150 and simplify it as negative 125 minus 25. This form of simplification allows us to solve our equation smoothly. If you look closely at our two numbers, we know that 125 is a cubic number. It is 5 to the power of 3, right? And then we look at our 25, that's actually a squared number, that's 5 squared. So taking these numbers can allow us to factor our equation. So let's go ahead and see how that helps us in our solution. So we have y cubed and we pair that with negative 5 cubed. Then we say plus y squared and we pair that with negative 5 squared. So we have y cubed minus 5 cubed plus y squared minus 5 squared is equal to 0. And if you look closely, we have the difference of 2 cubes and the difference of 2 squares. Now how do we factor these two expressions? Let's have a look at that. So we have the difference of 2 cubes, where we have a cubed minus b cubed is equal to a minus b in one bracket, and in another bracket we have a squared plus ab plus b squared. So this is how we expand the difference of 2 cubes. Let's look at the difference of 2 squares. So if we have a situation where we have a squared minus b squared, we can have a pair of double brackets, one being positive, one being negative, where we have a plus b in one bracket and a minus b in the other. So these are our two expressions, and this is how we expand these expressions. So we have the difference of two cubes, and the way we expand this is having a pair of double brackets where we have y minus 5 in one bracket, and in the other we would have y squared plus 5y plus 5 squared, or we could just say 25. So this is how we expand the difference of two cubes in this situation. So we're just going to add that to the difference of two squares, and again we expand the difference of two squares having a pair of double brackets again, one being positive and the other being negative. So we'd have y plus 5 in one bracket and y minus 5 enclosed in another pair of brackets. Now we can look at this plus operator that we have right here, and we can treat this as positive 1. And now if we look over here where we have y minus 5, we also see that we have y minus 5 by the difference of two squares. So essentially we can actually factor out the y minus 5 and include it here. And that positive 1 that I showed you earlier is a factor of our difference of two squares. So let us write out our equation. We have y minus 5 in one pair of brackets, and in another pair of brackets we'd have y squared plus 5y plus 25. And since the y minus 5 factor out this y minus 5, it means that we just have the 1 in bracket y plus 5. So we're just going to record that. So we have plus 1 and in bracket y plus 5. We close that bracket and we have all of that is equal to 0. We should actually have another closed bracket right there, but that's fine. You get the idea. Expanding our brackets in this situation, we would have plus y plus 5. So we're just going to add that in the other pair of brackets. So we have y minus 5 in one bracket, and in the other bracket we would have y squared plus 5y plus y. Then we would just add the 5 to the 25, so that's 25 plus 5. So that's what we would have. And then we would close our bracket, and that's equal to 0. So just to add like terms, so we have y minus 5 in one bracket, and in the other bracket we would have y squared plus 6y plus 30, as 25 plus 5 gives us 30. Close that bracket is equal to 0. So here we actually have two pair of brackets, and using our zero property rule, if we have two brackets multiplying together to give us 0, either one of them is equal to 0 or both of the expressions are equal to 0. So we would actually set our two pairs of brackets to equal to 0. So we have y minus 5 is equal to 0, and we'd have y squared plus 6y plus 30 is equal to 0. So for the first solution of y is that y is equal to 5, and that's a real solution. So over here we can use our quadratic formula to solve for y. So in this case, that means we would have a is equal to 1, b is equal to 6, and c is equal to 30. So as I said before, we use our quadratic formula to solve for y. So we would say that y is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So just plugging in our values that we have, where we have a, b, and c in our formula, we just plug in the values. So we'd have y is equal to negative 6 plus or minus the square root of b squared, not b squared, which is 6 squared, or negative 6 squared is equal to 36, minus 4 times a times c is going to give us 120. And we have all of this over 2 times a, or that's just 2 times 1, which is just 2. So just to work out what we have here, we have y is equal to negative 6 plus or minus the square root of 36 minus 120. So 36 minus 120 is going to give us 84. So we have negative 6 plus or minus the square root of negative 84 all over 2. So then we would have y is equal to negative 6 plus or minus the root of, or the square root of 84 times the square root of negative 1. So we factor out negative 1 in this situation, and we have all of this over 2. Now the root of negative 1 is referred to as I, or imaginary number, because this is a complex solution. Then we look at factors of 84. We have 12 and 7, and 12 can be factored out as 4 times 3. So we have 4 times 3 times 7. And if we look here, we can actually simplify all 4, and that's why we use these factors. So let's go ahead and see what that looks like. So then we would have y is equal to negative 6 plus or minus, we would have in this case the square root of 4. So we're just gonna have just the square root of 4 here, times the square root of 3 times the square root of 7 times the square root of negative 1. So I made a little error right there, should be times the square root of 7 as well. So we would have y is equal to negative 6 plus or minus the square root of 4 is going to be 2. So that's 2 times, we have the square root of negative 1, which is going to be I. So that's 2i times the square root of 3 times 7 is going to be the square root of 21. So that's all over 2. So we could rewrite that as y is equal to negative 6, and since it's all over 2, that's negative 6 over 2 plus or minus 2 times I times the square root of 21 all over 2. So we could simplify as say that 2 into negative 6, that's going to give us negative 3. So that's negative 3 plus or minus 2 into 2, that's going to give us 1. So we'd have plus or minus, we just have that as I times the square root of 21. So this is actually my second and third solutions for y, so in this situation. But if you look carefully, that this solution is actually referred to as a complex solution, but we are going to use our real solution to verify for the value of x. So just to continue from where we left off where we said that we're going to use our real solution to find the value of x. So we have the real solution that y is equal to 5. We also have it that y is equal to 2 to the power of x, as we had set that before. So that would mean that 2 to the power of x is equal to 5. Now we'll be using our logarithm to find the value of x in this situation. We have log 2 to the power of x is equal to log 5. Then using our logarithm rule, we would say that log x to the power of y is equal to y times the log of x. So using this logarithm rule, we'll just use this to simplify for the solution of x. So in this situation, we would therefore have x times log 2 is equal to log 5. So having this here, we can simply now divide both sides by log 2 to find the solution of x. So if we divide log 2 on the left, that's going to cancel out log 2. So we'd have log 2 being cancelled out on the left, and on the right we'd have log 5 over log 2. So that means that our solution for x is going to be that x is equal to log 5 over log 2. And using another logarithm rule, we can simplify for the solution of x, where we have log a over log b equal to log base b of a. This means therefore we can simplify for the solution of x as log base 2 of 5. And this is our solution for x. But we can go ahead and verify the solution to see if it is correct. So let's go ahead and just do that. So let's verify that x is equal to log base 2 of 5. So we're gonna go ahead and write back out our equation and simplify it, and then we're just gonna use some logarithm rules to see how we arrive at our solution. So we said that 8 to the power of x plus 2 to the power of 2 times x is equal to 150. We said before as well that we can simplify 8 to the power of x as 2 to the power of 3 in bracket powered by x, which is also simplified as 2 to the power of 3 times x. We have that plus 2 to the power of 2 times x, and we have all of that equal to 150. So using the value of x that we have, we said that x is equal to log base 2 of 5. So we're just gonna write this out and you plug in the value of x, and then we're gonna verify our solution of x. Now looking at what we have here, we have 2 to the power of 3 in brackets powered by log base 2 of 5. We know that this is, as we said before, the same as 3 times log base 2 of 5. Now using this logarithm rule where we have y log x is equal to log x powered by y. So if the y is in front of the log, then it's actually saying x to the power of y. So using what we just say, we would have 2 to the power of log base 2 of 5 powered by our 3. So that would be log base 2 of 5 to the power of 3, or 5 cubes. So we add that to doing the same here as well. We would have 2 to the power of log base 2 of 5 squared. So that's what we would have, and that's all equal to 150. Now looking at our two expressions that we see here, we will now use another logarithm rule to simplify these expressions. So our logarithm rule states that x to the power of log base x of y, where we have the same base x and x, then therefore it's equal to y. So what are we saying here? If we look at our equation, we see where we have 2 powered by log base 2 of 5 cubed. So here we have the same base, the 2 and the 2. So we're just going to use the same principle. We have the y. So the y would be the 5 cubed. So we'd have 5 cubed, and we would have that plus. And if looking at our 2 log base 2 of 5 squared is the same thing, the 2 and the 2. So we would use 5 squared. So that's 5 cubed plus 5 squared is equal to 150. Now in verifying our solution for x, we can look here where we have 5 cubed, and we know that 5 cubed is 125. So that's 125. Now we would have that plus. We see here as well we have 5 squared, and 5 squared is 25, as 5 times 5 is 25. Now if we look now, we have our solutions verified, because as we already know and work it out that 125 plus 25 is equal to 150. So our solution of x is now verified. Now I want to say a special thank you for staying in tune with me to the end of this video. I know that this video was a lengthy video, but I hope it was as informative as it is lengthy. So I hope you enjoyed this video, and if you like more content like this, please smash that like button, subscribe and share my video, and stay tuned for more. And until then, I will see you in the next video. Take care.